So we could look at an ecosystem's health, and we can make the analogy to our own health. And when we talk about health, generally that has to do with homeostasis and balancing the internal environment. Also, when we're talking about human health, we're talking about the absence of disease, and then also the ability of the body to withstand disease. So those are some things that we could look at in terms of ecosystem health as well. So we could say absence of disease, and the ability to cope with disease. So when we're talking about health of ecosystems, we're also talking about, in terms of disease, that would be like a disturbance. And so there are other things that disturb ecosystems. So maybe a better measure of ecosystem health would be the ability of the ecosystem to withstand a disturbance and to return back to its original state. So we could say that it could also be the potential of an ecosystem to withstand disturbances. And to a return back to its original state. Now, sometimes when disturbances are too great, we could have catastrophic shifts. And a catastrophic shift is where the disturbance has actually caused a dramatic change in the ecosystem, such that it looks very different than the original ecosystem. So, for example, when we talk about coral reefs turning into dead rubble, that would be like a catastrophic shift, that we went from a healthy coral reef to one that became diseased, became ill, and underwent a very dramatic change, and we lose species diversity. So, or maybe we just have a lot of sea urchins rather than healthy corals and a diversity of other species. So one thing that seems to keep an ecosystem healthy is what we call redundancies in functional groups. So healthy, resilient. So after the disturbance, it's able to come back to, when we talk about systems, it's able to come back to its previous state. Ecosystems tend to have a redundancy in functional groups. Functional. And this is actually also a measure of its complexity. So, and diversity. So how many different species do you have, for example, that are the producers? How many different species do you have that graze algae? How many different species do you have that eat sea urchins, right? So we have these functional groups in the ecosystem. And if you have a great diversity of that, oftentimes if one of those functional groups dies off for whatever reason, the other ones will take over and will help to maintain the balance of the ecosystem. So we can compare different ecosystems and look at their redundancy and how resistant or resilient they might be to disease, to a catastrophic shift. So this is an example where we're looking at the functional groups here, like roving grazers, microcarnivores, sand invertebrates, right? So this is in a coral reef ecosystem. And we're comparing the Great Barrier Reef to the Caribbean. And we can see that the Great Barrier Reef has more species. So this is the number of species down here. So it has more redundancy. So it probably is going to be able to withstand catastrophic shifts and come back to a normal, what we would consider healthy coral reef situation where you have some stability compared to the Caribbean. And we can also look at like diversity in corals here, where we can see that there are many different types of corals in the Great Barrier Reef, but maybe not as much, not as many in the Caribbean. So again, we're hopeful that with global warming as being a disturbance, we do not want the coral reefs to completely undergo a catastrophic shift where the coral all bleaches and then you get this massive decline in the health of that ecosystem. And so we're hoping that some corals will be able to withstand this disturbance. We can also see this if we look at what kind of disturbances besides warm temperature are influencing coral ecosystems. So here on this axis, we have extra nutrients. And so too many nutrients like pollution runoff, like fertilizer runoff, can really stress, sewage runoff can really stress a normal reef. And you can see that it loses its diversity. Here it becomes just kind of slimy sea urchin territory. Fishing pressure oftentimes is caused by dragging nets across the surface of the coral, and you can imagine how destructive that is. And that could actually lead eventually to our coral reefs just becoming barren rock. And so here we see that there is a lot of stability in our healthy states, and there's resistance to change, right? So we have this stress. With overfishing, it takes it to a state where there is just way too much large algae. So this is the macro algae state. And then if we get over this period where we actually cause more disturbance, then the sea urchin and the coral reef is just going to eventually go to barren rock. And so here we have an unhealthy ecosystem. So there are mechanisms that the ecosystem has in order to resist these dramatic changes. But sometimes the disturbance is just too great, and then it causes the ecosystem to collapse, essentially.